The Earth's magnetic field is getting weaker. Now, since a guy named Gauss, G-A-U-S or G-A-U-S-S, I taught science, not English, but Gauss began measuring the strength of the Earth's magnetic field. How strong is the magnetic field of the Earth? They've noticed since he started doing that, in the last 150 years, the Earth's magnetic field has lost 6% of its strength. If we have lost 6% of our strength in 150 years, the theory is that probably the decline in strength will follow what's called a logarithmic digression instead of a linear digression. Let me show you the difference here, what that means. If you go backwards in time, this would be linear, meaning a straight line. If it goes logarithmic, it may be like this. And without getting into all algebra and geometry and trigonometry behind this, these are called two different progressions. For instance, if you doubled the amount of money in the bank every year, or every day, or every month, or whatever. There's the story told about the guy who's told his friend, he said, I will give you $100,000 a day for 30 days. If you will give me a penny the first day and double it for 30 days. Double it every day for 30 days. If I made you offer 1 or offer 2, which one would you take? Offer 2. You get a lot more money. Now for the first 20-some days, this guy racks up the dough, man. After about 20 or 22 or 24 days, somewhere in there, it starts to really eat him up, and all of a sudden he loses it all in a hurry. This would be a logarithmic or a geometric progression. Malthus was all upset because he thought that the population would increase geometrically and the food supply could only increase arithmetically or linear. Now he's wrong, but that's what he thought. And that's what got Darwin all upset, saying, well, if there's more people born than can survive, then only the weakest should die off and the strongest should survive, and that's the way it's supposed to work. That's all led to Darwin's thinking. So the Earth's magnetic field, we've only got a short piece of data to measure. You got a series of points for 150 years. Based on that short section of information, you have to decide, is it going to be a geometric or a linear? Either way, it creates a problem for the evolutionist. It creates more of a problem if it's geometric, but even if it's just a linear digression or progression back into time, it still creates a problem. Thomas G. Barnes at University of Texas, El Paso, taught physics there for years. He said that the Earth's magnetic field is declining at such a rate that it cannot be more than 25,000 years old. He said if you go back in time, actually I've kind of got it backwards here to where normally the way you'd look at a graph, it's declining. The strength is declining. This has been measured, let's call this the year 2000 and this the year 1850. As the magnetic field gets stronger and stronger and stronger, this would indicate a hotter center to the Earth, or more movement. If you go back in time, how far back can you go before there's too much heat? And he calculated at 25,000 years ago is the limit where life could not exist on Earth. Now, there is no question in anybody's mind that the Earth's magnetic field is getting weaker. That is never questioned by the atheists or evolutionists or anybody. They all agree it's getting weaker. How do you handle this data is what the problem is. The creationist says, well, this proves the Earth is young. The evolutionist says, no, this is just part of a cycle. It's declining now, but it's reversed through the years. Remember we talked about magnetic reversals? There are no magnetic reversals at the bottom of the ocean floor. But they say, well, the Earth's magnetic field is reversing. This idea of continental drift and Earth's magnetic field reversing, flipping, is all, I think, a very desperate attempt to salvage the billions of years they need for their theory to look reasonable. When the simple fact is, the Earth is not billions of years old. Okay, so the magnetic field is declining. And this indicates less than billions of years, certainly. It indicates it cannot be billions of years old, and this indicates carbon dating cannot work. Now here's why. The Earth's magnetic field, as it declines, it allows more radiation to get in. One of the protective barriers we have around the Earth is our magnetic field. Hang on here. There we go. The magnetic field protects us from radiation, along with several other things the atmosphere has. But if the magnetic field is getting weaker, more radiation gets in. And it's that same radiation that makes carbon-14. So if the magnetic field was stronger in the past, you would have less carbon-14. So any plants that were breathing this carbon-14, if we're going to check them against today's standard, we're automatically going to get a wrong number because they had less. So the magnetic field is one of the factors affecting the amount of carbon-14 in the atmosphere. Textbooks are going to say the Earth's magnetic field has reversed. This is a typical textbook saying there are areas of reversed polarity. Now the reason they teach this to the kids, even though it's not true, probably the author of the textbook does not know that it's not true. He thinks the Earth's magnetic field has reversed. Let me explain what happened. They dragged a machine across the bottom of the ocean, and plus they did drilling to drill down, bring up samples of rock, and see how strong is the magnetic field in this rock. When you get into iron or magnetite or metals, rock that will store a magnetic field, they can check how strong is the magnet. Measure it with so many Gauss or whatever units they use for measuring the Earth's magnetic field. They find out there are areas of stronger and weaker magnetism. And so what they did, they graphed out as they moved across the bottom of the ocean. They said, oh, here's an area, here's stronger here. Now it's weaker, weaker. Oh, stronger, stronger, weaker, weaker. And it made a wave, a sine wave they call it. It goes, curves up and down. It was weaker and stronger and weaker and stronger and weaker and stronger. Some guy drew a line through the middle of the sine wave and said, everything below this line is a reversal. And right there's where the problem is. It wasn't a reversal, it was just weaker. If we lined up everybody in the world and found an average height, we'd have short people, tall people, short people, tall people, short people. We draw a line through the middle, find the average. Is everybody below the line underground, or are they just shorter? They're not underground, are they? They're just shorter than the average, that's all. And everything below the line was just less than the average intensity. It was not a reversal. Now how they get by with this, I don't know. But I think nobody ever checked out the truth is what happened. There are no magnetic reversals on the ocean floor. Only areas of stronger and weaker magnetism. Okay, suppose you can prove there are no magnetic reversals, only weaker areas of magnetism. Now we need to come up with an explanation for why is one area weaker than the others, and we've got that on video number 6. We'll get to that. But what does this do to the evolutionist? You just took away the idea that there are reversals. So now you go back to your original problem. The Earth's magnetic field is getting weaker. So how old is the Earth? If he wants to believe it's billions of years old, now he's going against some clear scientific evidence. It can't be billions of years old. That's for sure.